Okay, we're on the a section of the notes that some students are going to find difficult because we do some derivations. I do want to claim, though, if you're not interested in derivations and you want to memorize formulas, that's fine, right? A lot of times it's really tough to follow a derivation, but here's the issue. This section over here, I will go through the derivations. If you're going to glaze over while I'm doing a derivation, that's fine, understandable. Here's the deal, though. You're going to need to know 4 formulas at a minimum. Number 1, which is the cosine of a difference. Number 2, which is the cosine of a sum. You're also going to need to know the sign of a sum and the sign of a difference. So there's 4, and they're numbered for you. 1, 2, 3, 4. We're going to derive all 4 of those at the whiteboard. It's going to be tough for a lot of students at nightmarish. These 4 need to be known to do the problem set. From these 4, though, I'm going to claim it is really easy to use these 4 to derive what's known as a double angle formula, which we will go through at the whiteboard, half angle formulas, which we'll go through at the whiteboard, and product sum formulas and sum to product formulas. So let me repeat this. It's important that you can remember from this lecture, formula number 1, formula number 2, formula number 3, formula number 4. They're super important. All right, I'm going to switch over to the whiteboard now, and I'll attempt to derive the formulas. And certainly, if you're, not terribly interested in that, that's fine too. But I do want to emphasize that I think your interest should be in not accepting something, but trying to verify that it's true. All right, let's do a new share. And we're at the whiteboard now. So what I'm going to do is, I'll talk you through this sum formula. And the sum formula I talk you through is actually the cosine. I'll write this on the side for you. We want to derive cosine of A minus B. All right, we want to derive that. The question is, what is it? All right, so the way we're going to do that, I'm going to draw a picture. I'm going to put 2 angles down. I'm going to put an angle B down. This is angle B. And I'm going to put another angle down. And this is just arbitrary I'm doing, but I do want to make A bigger than B, at least visually in my diagram. And I'm going to say this is A over here. This is A. All right. I'm going to say it's a unit circle. I'm going to put points down now in the unit circle. And what I mean by that, there's a circle here. Not very great looking, that's a quarter circle, but there's a point here and there's a point here. I'm going to write down what those points are. And this is a unit circle. Well, the point for this one, the red line, that's a terminal side, is going to be cosine of B, comma, sine of B. All right, that's pretty simple. And the point on the blue line is going to be cosine of A, comma, sine of A. And what I want to do is I want to talk about the distance between those 2 points. You should know from Math 100 there's a distance formula. Let me write that down for you. What's the distance going to be? The square root. Now it's going to be cosine A minus cosine B squared plus sine A minus sine B squared. I'm going to work through that, but I'm going to write down D squared instead, because I don't like to write that square root symbol all the time. And I'm going to write down exactly what you'd get. You'd get cosine squared A minus 2 cosine A cosine B. I'm expanding the cosine A minus cosine B squared, and I'd get plus cosine squared B. Now I'm going to square that sine A minus sine B term. What do I get over there? I would get sine squared A, this is added on, minus 2 cosine A. I'm sorry, I misspoke. Let me go backwards. I'm sorry, it's sine A, sine B, plus sine squared B. All right, let me just talk through this. And I'm seeing Pythagorean identities now. I'm saying that this plus this would be 1, and this plus this would be 1. And 1 plus 1 is 2. So I'm write that down for you. So d squared is equal to 2 minus 2 cosine A cosine B minus 2 sine A sine B. And yes, I realize for some to say that's too much work for me. I don't want to do that. Well, we're not going to force you to do that. We're just trying to explain where the formula comes from. Now what I'm going to do is I'm taking the angle A and I'm going to subtract B from it. And I want to visualize that for you. So I'm going to take the angle A and I'm going to subtract B from it. And I want to visualize that for you. All right. So when I visualize, I'm not going to say my graphs are great, but if you took A and you subtracted B from, what happens is this thing's going to rotate down, and I'll put that down for you now. And this now is the angle A minus B. Here's what happened though. Everything gets rotated, B units clockwise. So let me point out what happens here. This point here gets rotated down B. This point here gets rotated B. Where would it be? Right here. I'm going to put that down now for you. All right, we still have our circle. Our circle looks like this. All right, let's write the points down now, one at a time. What's this point over here? If it's a unit circle, it would be 1, 0. What's this point over here? Well, it's really not that bad. It's cosine A minus B, so it's over, comma, sine A minus B. Now what I'm going to claim is the distance is still the same distance. So we still have this D problem, and I'll write down for you. The D is still the same thing. It's still the same distance. We just rotate the whole diagram B units clockwise. All we've done. So what do we get over here? D equals, let's write this down now. It's going to be cosine A minus B minus 1 squared plus sine A minus B minus 0 squared. Well, you know what? Just like I did before, I'm going to write down D squared now. And I'm just removing the root symbol. Remember, D is still D. What do you get over here? You get cosine squared A minus B minus 2 cosine A minus B plus 1. I just squared the first term. Second term is really easy to square. What do you get? Plus sine squared A minus B. So what am I noticing now? D squared, well, cosine squared plus sine squared, same argument, A minus B is 1. 1 plus 1 is 2. And yeah, I realized a lot of work. All right. So what I'm going to write down is if these things are equal, I'm just going to equate the two now. So 2 minus 2 cosine A cosine B minus 2 sine A sine B is identical to 2 minus 2 cosine A minus B. Well, what I'm going to do is I'll subtract 2 from both sides. That's pretty simple. And what would you get? Well, let's write it down. Minus 2 cosine A cosine B minus 2 sine A sine B equals minus 2 cosine a minus b. Now what I'm going to do, divide both sides by minus 2. What are you going to get then? Something really simple. You're going to get cosine A times cosine B plus sine A sine B is equal to cosine A minus B. That was a lot of work. All right. So what I want to claim over here is this is one of the formulas that we've just given you. And I'm going to put a box on it indicating you need to know that. And what did we just do? We just did this. This is number one. This absolutely needs to be known. Now, someone's going to say, do I need to know how to derive it? No, I wouldn't ask you that. All right. Here's the deal, though. It's nice to know where it came from, and we just derived it. Now, from this simple fact, we're going to develop the others from it. And let's do one at a time. So what I want to do is I want to use this cosine A minus B to find out what cosine A plus B. Well, I need to write it a little differently. And what's going to be cosine A minus B. Now, I realize that seems like a lot of work. We're just going to go through it. And I'm looking at number one formula. What's it going to be? Cosine A times cosine of minus B plus sine of A times sine of minus B. Now what am I going to do? I'm going to use what's known as even odd identities. And you should know that the cosine of minus B, it's an even function, is the same thing as cosine of B. I'll write that down for you. So cosine A, cosine B. You should know that sine is an odd function, and the sine of minus B is identical to minus sine of B. So what do you get over here? Minus sine A, sine B. So the cosine of A plus B is cosine A, cosine B, minus sine A, sine B. Let me point out where that is, right over here. That's the second formula. All right, derivation. Now, granted, someone says that the first one was really tough to come up with, but the second one wasn't so bad, provided you knew the prior material. And that's where study comes in. Do I know the prior material? So what I'm going to do now is I'm going to pull this on the side. And I want to talk about this now. All right. And again, certainly when someone's talking through, she says, you know, what's the outcome? I see the outcome, and we'll talk about that when we get back to the notes. There's two more formulas that we need to derive. So I'm going to claim looking at it, you know, the sine of theta using a cofunction identity. This is a cofunction identity. Whoops. Yep, we've done that. We've derived that. The sine of theta is the same thing as the cosine of pi over 2 minus theta. All right. So what I did was I make a replacement for theta. I just simply say, oh, theta is A plus B. All right. So I write that down. Instead of writing sine theta down, I write sine A plus B. And then over on the other side, the right side, I just simply, in place of theta, I put A plus B down. Then what do? Well, I don't write, you know, sine of A plus B, I just leave it alone. But the cosine, I kind of put it into two different terms of parentheses. So it's really the same thing as cosine pi over 2 minus A minus B. That's all it is. All right, then what do? I use the identity that I know from prior, and I write it down. So it's going to be cosine of pi over 2 minus A times the cosine of B plus the sine of pi over 2 minus A times the sine of B. I'm just using a prior identity. Then what do I know? Well, I know the cosine of pi over 2 minus A using a cofunction identity is the same thing as the sine of A. all right? And I know the sine of pi over 2 minus a is the same thing as a cosine of a. So then I've derived another formula, and it's called the sum formula. I've derived the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. All right? This is another formula from the notes that you need to know. All right? It's probably on the next page. I'll get to the next page in a second. Let me put another one down for you. And I'm going to write this one down here as I'd like to know what the sine of a minus b is. And the way I'm going to do that is write down sine of a plus minus b. What do I go over there? Well, I'm going to use the formula. Sine of a cosine of minus b plus, let's see, sine of, I'm sorry, I should write in the same order. I apologize for that. And I'll talk about that later. I don't want to try to confuse you with writing in different order. Whoops, let me just erase that. And it's like I get carried away with order. Multiplication is commutative though, but it would be cosine A times the sine of minus B. Well, let me write this down for you. And I'm using even odd identities that we used before. The sine of A and cosine of minus B is the same thing as cosine of B. And then the sine of minus B is the same thing as minus sine of B. All right. So I got another identity. So I'm going to say the sine, and I'll put a box in this one over here. The sine of A minus B is anything as sine of A, cosine of B, minus cosine of A, sine of B. We'll certainly go through examples, but right now, I just want to go to the next page. All right. I want to show you where these formulas are. By the way, I want to point out, you can commute multiplications around. You can also commute additions. All right. So what have we done so far? I have two formulas box. Number one, I said you need to know that. And number two, you need to know that. We'll certainly go through examples. Let me go to the next page. And these things are also boxed off for you. You need to know this. And you need to know this. Okay. Now what am I going to do? I'm going to use a double angle formula. All right. And I'm going to derive them, but I'm not going to box them. I don't really need to remember these things because I can derive them pretty quickly. So I want to go to the side and I want to derive the cosine of a double angle. And I'm going to call it 2x. And I want to derive the sine of a double angle, and I'll call that angle 2x. So I would need to know some formulas. And what formulas do I need to know? The cosine of a sum. Whoops, sorry about that. And I would need to know the sine of a sum. And this is where the four formulas are going to come into play. And we'll talk about what's written down over there in a second. Let me do sine first. What's it going to be? Sine x times cosine x. You may wonder what formula I'm using. I'm using formula number 3 now. I'm going to cue things around just to make it a little bit neater for me. And this will be plus sine x cosine x. So I'm going to claim the sine of 2x is the same thing as 2 sine x cosine x. And somebody say, oh, you put a box on it. Do I need to remember that? I'm going to say maybe it would be important to be able to derive that. And maybe after deriving a few times, you'll memorize it. Let's put the next one down, which is cosine of 2x. And again, some of what formula you're using from the prior page. That's going to be cosine x times cosine x minus sine x times sine x. Well, I got something pretty interesting here. A ton of what I got over here. Let me just try to get rid of the, I'm going to go for simple. I'm going to write down the cosine of 2x is the same thing as cosine squared minus sine squared. That's a double angle formula. All right, I'm going to put other ones down for you. Don't be alarmed. It's written in your notes. Well, cosine squared x minus, I want to point out the sine squared could be written as 1 minus cosine squared. So cosine 2x is the same thing as 2 cosine squared x minus 1. Put a box on as well. Let's do the next one. Cosine of 2x. Well, I could write cosine squared as 1 minus sine squared. I want to put what I'm doing here. I'm looking at this, and I wrote this down instead, and it's minus sine, right? Let's write that one down. Cosine of 2x equals 1 minus 2 sine squared. All right. I want to go back to the notes. I want to point out where these formulas are given to you. And certainly, I'm not going to say you need to memorize this, but it sure is nice if you can do it. All right. When I say do it, derive it from the 4 prior. So I'm going to say we just did that one. We did this one. We did this one. We did this one. All right. We are going to use those to derive half angle formulas, which is the next on our list. All right. I'm not going to say it's going to be easy for you. All right. What I want to do is I want to pull this to the side. And give me 1 second to do so. Let me just over here, whoops, I'm sorry about that. I didn't mean to do that. Okay. Let me go back over this and tell you where these are coming from. So we just derived something. What do we derive? We derive the cosine of 2 theta. No, I think I used x, didn't I? I'm sorry. Equals 2 cosine squared x minus 1. We just derived that. I hope you remember that. And also we derive the cosine of 2x equals 1 minus 2 sine squared x. What I want to do now, I want to let x equal theta over 2. Well, let's write that down now. What are you going to get? Cosine. Well, 2 times theta over 2 is just theta. Equals 2 cosine squared. Well, x is theta over 2 now. Let's do this one over here. It's going to be cosine theta equals 1 minus 2 sine squared theta over 2. And yes, I know it's a lot of work. I'm going to rearrange. This is going to be 2 cosine, whoops. I have a tendency to get jumpy with this, don't I? Two cosine squared, whoops, theta over 2 is going to be cosine theta plus 1. Now, sometimes what you do there, I just added 1 to both sides, and since equations are reflective, I just rearranged a little tiny bit. So what do you get over here? Cosine squared theta over 2 equals cosine theta plus 1 over 2. What I do, divide both sides by 2. Now I can write a half angle formula down. And again, we'll go through work later. Here's the problem, plus or minus. All right, let me tell you where this one is. It's right over here. We just did that. Let's do the other one. And I'm going to rearrange this guy too. So it's going to be 2 sine squared theta over 2 equals 1 minus cosine of theta. I'm going to divide both sides by 2. And what do you get there? Sine theta over 2 equals plus or minus, we're using the square root rule, 1 minus cosine theta over 2. All right, let me tell you where that is, right here in the notes. And I want to go back to the notes itself. And I'm going to say, sometimes I need to memorize that. I can't derive that. Well, you got some memorization then. What are you memorizing over here? This business over here. You need to memorize it. By the way, I want to point out this is an interesting one. In one of the assignments, you're going to show that's true. But right now, I wouldn't worry about it so much. What I'd worry about is you got a sine and a cosine now. By the way, if I know sine and cosine, I certainly know tangent. Not that bad to derive. All right, let's go to the next page. And this is where a lot of students say, this is just getting overwhelming. I mean, do I really need to do all that? And I got to be honest with you. It would be nice if you could try. All right. So let me write down. I'm not going to write every single one down, but I'm going to point out that if you were to write down, I'm going to write something down for you. I'm going to write down, I don't know, the cosine of A plus B equals, and I think you should know these guys, cosine of A minus B equals the sine. These are the 4 you should know, by the way, A plus B. And you should know the sine of A minus B. Now, why do I say you should know those? So if you know those 4, you know double angle formulas from those 4. You'll know half angles from the double angles. And now you're going to know the product and sum formulas from these 4. I don't want to go through every one, but I will go through some. All right, let me just put one down for you. This would be cosine A, cosine B, push this over, minus sine A, sine B. This one's going to be cosine A, cosine B, plus sine A, sine B. This is going to be sine A, cosine B, plus sine B, cosine A. This can be sine A, cosine B, minus a B, minus sine B, cosine A. What I notice about these 4, I want to point out many things you can notice about these things. And you may say, why would I want to notice? Maybe it's pointless, but there is application to this. When you move forward in mathematics, you're going to be using formulas like this. I want to add these 2 together. And what would you get? Cosine A plus B plus cosine A minus B is going to be 2 cosine A cosine B. Okay, I'm going to tell you what this is. This is a product to a sum. I took a product and write a sum. Someone says, is that important? It is, because sums are easier than products. This reminds me of what we did 119 with log functions. All right, let's put another one down. And not that I want to write every one down. I'm going to add these 2 together. And let's write there what you get. What'd you get over there? Sine A plus B plus sine A minus B. Well, what'd you get over there? Well, let's say you get 2 sine A cosine B. All right, what I did over here. Product to a sum. Super important. By the way, I don't want to go through every single variation in this, but you should start to realize you could be here all day doing this, adding them together, subtracting them. All right. Now, someone says you read something a little bit differently, and I want to point out. I want to look at one of them. I want to look at this one right here. I'm going to pull it on the side. Give me 1 second. And I'm going to pull on the side. I want to look at it. All right. Let's take a look at this one over here. And someone says, where'd that one come from? Well, sine A cosine B, right? What did they do? They divided both sides by 2. That's all they've done. And we're getting the formula that we have over here. All right, that's formula number 9. Let me look back over here. And again, look for the other one, cosine A cosine B. That's formula number 11. Let me just blow it up a little bit. Pull it over here. We're doing number 11 now. So I'm going to claim over here, I definitely see the cosine A cosine B. What did they do? Divide both sides by 2 instead. Or would they get cosine A plus B plus cosine A minus B? So we derive both those formulas. All right. So someone says, well, gee whiz, what are you going to do now? Well, you could also write down what's called sum to products. And basically, I have them down for you already. I have sums down. I'll point it out to you. I have a sum down written as a product. Right? So these, let me just go back to that. Push this on the side. Again, these might be overwhelming, but I got to be honest with you. They're pretty easy to add those sum formulas together and get this. And from these, although this may seem complicated, we'll do those as well. All right. Thank you.